All right, this is example 5b in section 2.4, and it's an example where we have some overlapping squares, and these are a little bit trickier. So they were kind of gave it away when how I introduced it, but you need to look at the two squares in this problem. So we have first this one here. Let's call that square 1. And then we have this square here. Call that square 2. So there's some overlap here. So let's look at how we can treat that. So let's first and I'll put a point here. Let's first look at how many moves it takes us to move through square A to this point in the middle. And I can call it C again like we did in the last example. So from A to C and I'll do my moves in red here. So we're going to go 2 moves east and 2 moves south. Okay, so east, east, south, south, like that. So for a total of 4 moves. So we'll write that like that, which gives us 6 routes of getting from square A to square C, or point A to point C. So now let's look at getting from, I'm going to put another dot point here, but this is at the top of this square, our second square here. So I'm going to call that one D, and let's go now from D to B. So, and I'll go down the side here. So we need to make 3 moves south, 2 moves east, south, 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 east, east. So we've made 5 total moves now. 3 of those need to be south, 2 of those will be east, which gives us 10 routes. And now we need to account for the overlap. So, because what we've done now is made this a problem. So far, we've treated it as a problem like in A, where there's no overlap, and the squares are joined at the point. So D and C would be the same. But we want to find out the total number of routes it takes to get from A to B, so including the overlap. And we want to cut it out by dividing the number of moves that it takes to get through the overlap. So divided by our moves that we've counted twice, right? We're going to get those out of there. So you should be able to see that no matter where you start, to go from point D to point C, there's always 2 moves. So I'll say the overlap is point D to C. And there's only 2 ways of doing that, so it's 2 factorial. There are no repeating points, so there's just 2 ways of doing that. So then the total number of routes, so the total routes would be the AC routes times the DB routes divided by the overlap, which would be, in our problem here, are DC routes. So that gives us 6 times 10 divided by 2 is 60 divided by 2 is 30 total routes. That's a little trickier, but it is still follows the same few steps. It's just now you got to look at making sure you get rid of things that have been counted twice.